4x4 membrane keypad. Keypad allows user to input data while program is running. A keypad is often needed to provide input to an Arduino system, and membrane-type keypads are an economical solution for many applications. They are quite thin and can easily be mounted wherever they are needed. In this tutorial, we demonstrate how to use a 16-button alphanumeric keypad with the Arduino. Here is the connection diagram of this project. 16x2 LCD display has 2 lines. Each line can display 16 characters. This display has 16 pins. First pin is ground, second is VCC, then contrast, RS, RW, enable, D0, D1, D2, D3, D4, D5, D6, D7, VCC, and ground. Pin 1 and 2 provide the supply for its internal circuitry, and pin 15 and 16 provides the supply for its backlight. We have connected pin number 1, 5, and 16 with the ground pin of Arduino, and pin number 2 and 15 with the 5-volt. Pin number 4 of LCD is connected to the pin number 12, and pin number 6 of LCD is connected to the pin number 11 of Arduino. Pin 7, 8, 9, and 10 are not used. Pin 11, 12, 13, and 14 of LCD display are connected to the pin 5, 4, 3 and 2 of Arduino respectively. A 16-button keypad has 4 rows and 4 columns. It has 8 output pins. 4 pins are connected with the rows, and 4 pins are connected with the columns. Pressing a button will short one of the row output to one of the column output. From this information, the Arduino can determine which button was pressed. For example, when key 3 is pressed, column 3 and row 1 are shorted. Arduino detects it and inputs 3 to the program. We have connected row 1 of keypad with a 0 pin of Arduino, row 2 of keypad with a 1 pin of Arduino, row 3 of keypad with a 2 pin of Arduino, row 4 of keypad with a 3 pin of Arduino. We have connected column 1 of keypad with a 4 pin of Arduino, column 2 of keypad with a 5 pin of Arduino, column 3 of keypad with pin 0 of Arduino, column 4 of keypad with pin number 1 of Arduino. This is the code of our project. To control the LCD display, we will first include its library in the program. To include the library, we will write in the first line #include liquid crystal.h. Now we will declare the name of the used pins in the sequence of RS, enable, D4, D5, D6, and D7. We have connected RS pin of LCD with pin number 12 of Arduino, D7 of LCD with pin number 2 of Arduino. Now we will include the library of the keypad. To include the library, we will write #include keypad.h. Now we have declared 2 variables. One is rows, and second one is columns. We have given value 4 to both the variables, because we are using 4x4 keypad. Now we have declared a 4x4 2D array, hexa keys, and give the name to each array location. Now we have declared 2 arrays, row pins and column pins. Each array has 4 locations. In this array, we have declared that which pin of Arduino is connected with the row pin of keypad, and which pin of Arduino is connected with the column pin of keypad. This line will take the values of variables from the previously defined values. Void setup is a function in which we have initialized the LCD. LCD.begin 16,2. It means we are using 16 columns and 2 rows of the LCD display. Void loop. This function will run over and over again, so whatever we write inside, it will repeat forever. Char custom key equal custom keypad.getKey. This function will scan the keypad. If any key is pressed, then variable custom key will store the name of that key. LCD.print will display the name of that key on the LCD screen. Now, we will write a code on this software. After writing the code, we will save our project. Now we will compile our code. For doing this, press this check button. If there is any error in the code, or the code is incorrect, it can be seen on the message screen below. If the code is correct, we can upload it to our Arduino hardware board. For this, we will first connect the Arduino board to the USB port of our computer. Now we will go to the Tools menu and select Arduino Uno. Then, we will go to the port option and select the port at which Arduino is connected. Now, to transfer this code to our hardware, we will press this arrow button. Now we will assemble our hardware. We will take 3 wires, 1 red and 2 black. We will use these wires later. Now we will solder a black wire at hole number 1 and red wire at hole number 2 of LCD display. Now we will solder a white wire at hole number 4 and brown wire at hole number 6 of LCD display. Now we will solder orange, yellow, green, and blue wires at pin number 11, 12, 13, and 14 of LCD display. Now connect hole number 16 with hole number 1 using a black wire, and hole number 15 with hole number 2 of LCD display using a red wire. Now connect hole number 5 with hole number 1 of LCD display using a black wire. Now connect hole number 3 with hole number 1 of LCD display through a 1 kilo ohm resistor. Connect the red wire with 5 volt pin and black wire with the ground pin. Now connect white, brown, orange, yellow, green, and blue wires with pin number 12, 11, 5, 4, 3, and 2 of Arduino respectively. Connect the gray wire of keypad with pin A0 of Arduino, purple wire with pin A1, blue wire with pin A2, green wire with pin A3, yellow wire with pin A4, orange wire with pin A5, red wire with pin 0, and brown wire of keypad with pin number 1 of Arduino. Now we will power up our circuit and test its functionality. We can see, as we are pressing the key on the keypad, Arduino is printing the same on the LCD display. I hope you enjoyed the video and learned something from it. For any help in your project, or to clear your doubts, you can contact us on our student care number 7007957715. To purchase the items used in the video, you can visit our website www.erolltech.com. You can order us on our WhatsApp number also. Thank you so much.